Kevin, let's get this party started.
Alright, and we got both legs done. Now what we're going to go ahead and do is we are going to start taking off the COM-8 side plates of the structural body. And here's why. So I know many of you are thinking, well, why doesn't he just complete the leg and go down to the feet and get everything together like that? Well, the important thing that we have to do is there's a lot of modifications that we have to make here on the part of the frame, and it needs to be able to fit this new hub. So this is now replaces the shoulder. Many of you have the original shoulder. So this is the original hub that went on the shoulder that provided the spacing. As you can see, it's just a smidge wider. Has the exact same pattern on it. Alright, but the important thing is it has this whole disc in the center. Now, why is that important? Well, this is where your wiring goes through here in the center, and it comes through. And it has this bearing. Right? So these bearings are what allows this whole thing in order to be able to rotate, so you can get the nice smooth motion of the leg to turn with very little effort. And then this is the inner portion, and this bolt comes through this leg slot as such. But as you notice, this and this don't match up. Okay? So this is where it's important. This is where we got to take off this next piece. So all of these small holes right here have to be drilled and tapped into the COM-8 frame. And we need to do that first to make sure that we have the body completely aligned and can do the actual shoulders. Otherwise, we're going to do all this work for these legs for naught. So we need to make sure we get all this right. And this is the pivot bracket. So basically, it goes up and down, pivots like this. This will have the motor that pulls it up and down on the shaft. This will pivot directly above these, like this. And then on one of these, actually the other one, is limit switches, which is what this tab is for, is it hits those limit switches so it knows all the way down, all the way up, and it's done. Alright, so now next thing we're going to do is we're going to go ahead and take off both the left and right side structural body of the COM-8, and we will show you as soon as we get done. We'll have both of them laying here, and I can show you exactly what I mean when it doesn't line up. Stand by. Alright, welcome back to This Old Empire. Remember, today we are working on making a modification to a COM-8 frame in order to put in Kevin's 323 leg system. Now, we've got the side plates off, and you can see R2, his body is here hanging. The only thing that is holding up his top plate right now is these two rear plates. So that is incredibly strong. The front carrier is off because I was working on that separately. And I'm rather impressed how it just kind of is hanging out there. So that's really cool. Nice job, James. Now, just kind of help people understand. Alright, so here is a COM-8 side structural frame. You can see here is the mounting point in which you put the ankle lock. So basically there is a bracket that goes through here with a nut and a screw. It comes down and then it has a steel threaded rod that goes down to the ankle lock that's actually down inside the foot shell that goes into the ankle. And so that allows it so that it stays all together rigid and provides rigidity. With Kevin's system, this is no longer required. So we talked about the plate sits on there behind like such, and allows the leg hub to rotate through those slots as such. Alright? Now, Kevin's system is slightly different. We showed you this hub piece that goes in here. Alright? Now, the way Kevin has this designed, it's originally designed for his frame system, which is absolutely phenomenal. NextDroid, totally doing Kevin's. Just the ability to do it would save me a lot of the workarounds that I've been designing and engineering, such as the magnetic skin snaps and a few other things. So this is a great opportunity, though, for those of us that have a COM-8 frame. How do we change it? Alright, so I took out the center spacer from the shoulder flange. Alright, and you notice it's in a D shape. Well, guess what that means? It slides in right there. So that ankle lock tab needs to get cut off. So I've already gone ahead and drawn this line with my straight edge. I'm going to go ahead and do this other side. Alright, now that we've got those tabs marked, we're going to have to go ahead, cut them in there. Dremel's finally cooled down, so it's ready to cut some more. And what we'll do is once we drop that in there, we'll be able to figure out we'll be able to mark the edge of this inner ring where all of those screws go through. Okay. And then we'll be able to lay this plate on top and see exactly where all the screw holes line up. Now I just realized this is off camera and you can't see what I'm doing. So let me rearrange a few things here so you can see better. Alright, try this again. So the D goes on and goes right in here. And what we'll do is once we take that tab off for the ankle lock, we'll be able to see where all of these spacers for where the screws go through. This will slide right through and is the exact same thickness as the plate. Then we can go ahead and put this plate on this way. And we can run a few screws through that will line up into the plate and allow us to make sure that we're perfectly aligned and we know exactly where to drill 2 holes. So the first hole that we'll have to drill is another one of these screw holes where it goes around. Now, would it be strong enough going around all of this? Probably. Never hurts to have a little overkill. And this is the one that the bolt goes through that goes and attaches to the leg. So now that we've already identified our cuts and I kind of explained where we're going to go, we're going to go ahead and fast forward a little bit and I'm going to start these cuts to remove these tabs off. Stick around. Alright, welcome back. As you can see, we have cut both of the tabs off of our COM-8 support frames. And we're going to take this in before I have parts and pieces all fall over the place. We're just going to do a quick test fit. Nice and easy. And nice and easy. So, we are on the right track. Now we're just going to go ahead and start with this one. And we're going to take this plate and start to line it up. Now we only need 2 screws to get us in place. Kevin provided all the hardware, so no concerns. We'll just run it down right there, and one down in right there. Get it in there. Okay, and we're going to mark the center of the hole, and it's not deep enough to reach through that, so we're going to use a center punch. So this is a center hole punch. What we'll do is it'll allow us to get right here and mark this spot. We're going to need our rubber mallet first. We're going to get this. I apologize for the bang in advance. Now, the benefit of doing this is we can now keep it from moving. Now very easily drop these on the drill press. We want them perfectly vertical. So now that we know exactly where we're at there, we're going to repeat the process on this one. Look at that, it just slides right out. But we're going to need to flip the part. Or we could just make it face the same direction. That's just as easy. Sometimes when you're working, you just make things difficult. Alright. And we line it up, center here. We're going to go ahead, save that piece from falling. Center there. And we're going to trace it off. Just make sure that we know where we want. And we got our trusty center punch. Apologize for the bang in advance. And there we have it. Now we're going to get these on the drill press and get the holes. Cool. All right. So this is a number 9 metal drill blade or drill bit, and then the larger one that we will use is a U for the other larger bolt hole. Anytime that you're going to drill through metal, you want to make sure that you have some good lubrication. I use the Tap Magic Pro Tap. It works great when you're putting taps in. It helps to ensure that you do not have any binding or I've actually broken several metal drill bits. The important thing is to use a metal drill bit, not a wood drill bit. I learned those lessons early on, when I started droid building. So it's, again, important to lesson learned. So here we go. Let's put the first hole in. Now I'm just getting off one of these screws that's supposed to go through there to make sure how our fit is. The problem is when you have little tap oil on your gloves, it becomes very challenging. So this is just a hair tight. Now the important thing is it doesn't need to be able to be uber tight on that. So what we're going to do is we're going to change out the bit and we're going to go to one size larger. Verifying a bit size here. So what we're going to do is we're going to change out the bit that we currently have, and we're going to go to a 13th 64ths. Just make it a little bit larger, a little easier to use. There's nothing wrong with that. We wanted to make sure that it was going to be a good fit. Tight. And it's okay, as I said, it's okay having to increase the size rather than going too big too first, and then you're left scrambling going, oh dear, what do I do now? Done that in other projects in life. Don't recommend doing it. It can leave things a little frustrating. Now, the important thing now is we're going to make sure we get it on the actual drill bit. Alright, because there's already a hole, so we want this to be able to help glide through and lubricate as it goes through all this aluminum. Now this really should go very quickly. Here we go. Alright, and we're going to test fit our screw through. If I can find it. And you got to get it through the hole. And it's a perfect fit. No resistance, so no binding. Excellent. Let's go ahead and place this other plate. So we're going to come right there, approximately. Make sure we're center of our hole. Looks good. Now the fun of reclamping. Francis C. clamps. If anyone gets that reference, I'll be pleasantly surprised. You know, because nothing's better than clamps. Clamps. You gotta see. Alright, and away we go. Alright, and it's going to take me just a second to get this bolt over here, and let's make sure that it fits. And it is a tight fit. So the question is, do we increase it ever so slightly? Let's see what that looks like, just out of curiosity. Get a better feel for what it's going to do. Everything is slippery with this Pro Tap cutting fluid going everywhere. So these gloves will have to be changed out for sure. As you can hear, that 3/16 is just a hair larger, and it keeps this bolt from binding up. I like the way that sounds a lot better, and it feels better too. So, as you can imagine, we change them. Now, the important thing to remember is with these, this is out of a tap kit. If you were going to actually be putting screw threads in, you would want it a little snugger like that so you can get those threads in. Alright, let's worry about cleaning up the aluminum later. Alright, so camera's back up. I got the drill press unplugged. And as you can see, we've got our holes. They're nice and easy to go through. No binding. Makes us happy. Alright, so there's our two legs, our two side plates. And we're just going to do a quick test fitting. Make sure that with everything in place, it all still lines up. Because you know how sometimes things go. And that is exactly what I was worried about. Ever so slightly off. I'm not sure what that was. Alright, let's make sure that the hole lines up. Make sure this lines up nicely. Right now it's not wanting to. And yes, I still have my gloves on from the drill press. I'm trying to ensure that if I have to use it again, I'm okay. Now, this is exactly what I was worried about. So our hole placement was ever slightly off. And you can see in here, perhaps, try to get it turned. There's a very small lip in there. So what I need to do is I need to enlarge that hole ever so slightly. So let's see what this other one looks like. See if we fared any better on our placement. Okay. Get everything lined up. Alright. That's through. And again, ever so slight out of alignment. So we will go ahead and mark these. That's right, that doesn't reach. And more than likely what we'll do is we'll just come in with a little bit larger drill bit, bore it out just a little bit more. That way nothing binds. It's there. It's not critical. Alright, so we're going to go ahead and turn the camera off. We'll get back to you in a minute after I get this all cleaned up and fixed. Alright, hey, we're back. Did a little troubleshooting to figure out what was going on. As you saw, we were using power tools trying to get those screws in. And I really started thinking about it. That's not necessary. So what I was able to figure out is that there was ever so slight binding between the top plate and the bottom plate and the spacer. So I used a number 6 drill bit to basically, I put 4 screws very carefully in, didn't put any nuts, just put the 2 flat nuts on there, just kind of hold it in place, and then basically went through the other 4 holes in order to basically kind of just open it just a hair. And then I moved the 4 screw holes, rotated 4, took the other 4 out, and again, used the number 6, went through. Now, those slide in and out, no friction at all, it's perfectly stopped. So the only thing that's holding those screws in there are these bolts. Then, we used a 25/64 bit, right here, and we went through the large bolt hole. Now, again, it was ever so off in alignment. Suggestion, so this side has a square fitting on it, and this side has a round fitting. So I took the drill press through the round side first, just keeping it in a line, and basically gradually took out a little bit of the edge on this side. It was just because this top plate was ever so slightly shifted, and its rectangular opening to hold the bolt in place was just out of alignment. So what this bit did is it basically enlarged. So if this was a square, so if this was the square that the bolt was sitting in, we just increased the curve on this side. So basically just kind of curved it out a little bit this way so that the bolt could slide in and out. And then we took our trusty Dremel with a small bit, grinding bit, and then we basically squared out this corner and this corner, just making it a little easier. And now that bolt slides right in and out, drops right in, very easy to do. So once that bolt slides into its place, it has the nut that goes on it, the spacer, washer, and then the lock nut. Now we don't take the lock nut all the way down because this will be one of the pieces that has to be reached through with a socket through the leg before the horseshoe goes on in order to get this attached to the linkage for movement. I hope that makes sense. Kind of go over it again when we do the other leg. And you know what? I'm just going to show you just to show how easy these are sliding in and out. We're just going to do one of these with the nuts, the simple nuts. So there's our nut. And that's how easy it comes in and out. That easy. As opposed, we were sitting there, you could hear this little Black & Decker screwdriver was just struggling away, was not getting what it needed to be done. So it just got rid of all the binding that was in there, just minor amounts. And like I said, this is not assembly. This is, astromech building. So there's going to be times where we have to make minor adjustments on the fly. And that's all that was happening. And if you'd like to see, we can show you the large nut as well. Since we're demonstrating everything, we'll just do that while we're here. Alright, so there's our lock nut, our washer. Always important to remember to put these in order. Our metal spacer. Our normal nut. And of course, it's a tight fit. So if you look closely, you can see here on the side, let me find something to play with. This is where we use the bit right here to expand this area. And then we ground this corner and this corner in order for the square portions of the bolt to fit in nicely. So just kind of watch. Drops right in. Bloop. All nice and tight. And then we just go in reverse order. Put our bolt back on. Or our nut back on, correction. Firm believer in having it tight. There we go. Spacer, washer, and our lock nut. We're just going to do that one hand tight. That's all we need. Alright. So that is the right side plate. On the right leg, this will go through the right leg, and then we'll pivot back and forth. So basically we'll pivot back. It's like this at the lowest point when it's in two-leg mode, and it rocks back in this position, which brings him back into three-leg. Pretty cool. It'll make more sense here in a minute. So let's go ahead and do the other side. Alright. Now this one is a little bit different. Let's go ahead and get these components off. So we got our lock nut, washer, spacer, our regular nut, and the bolt. Okay. Now, what makes this so much more different? Oh, there's cool gee whiz stuff on here. Plus, this plate is a lot larger. Just in comparison, you can see, sorry, let's get the same sides, how different it is. So these are limit switches And this is what will control the forward in motion on the yoke once it goes, so it knows when it's reached its various positions. So we got to take care of this piece. We're going to go ahead and get this off. I'm going to go ahead and take this back out of the way. Now, you could absolutely just run a smaller bit through, and it doesn't have to be as large as the thread, which is what I did with that number 6. You could run a slightly smaller one, possibly say maybe a 16 or a 19. You could run that through there, it'd be a lot smaller, and it, then if you wanted to actually tap it, you could. But you know that I'm looking at this, and the amount of threading that it's trying to do in there is so minor. I'd have to go to another size screw in order to get some actual good threads on that, and that's just not worth it. That's what those nuts are for, is to do all the work. So let's just make it easy so it goes in and out. Alright, so drop it in. And let's make sure we got this oriented properly. So this is going to be towards the rear, which makes this the outside, which means this piece should go on like that. And it doesn't line up, which means we got the holes on backwards. There we go. So now we got that one basically oriented. We're going to go ahead and take the limit switch. We're going to set it. Get it on just like that. And we're going to have the same challenge again. So what we're going to do is not panic, first and foremost. We're going to get this aligned. We're going to try to get that bolt just kind of started. Not looking for perfection. Just enough that we can get it started. In there, so we have a good base. So there's the first one. Where are we going to do our next one? Let's see. So the trick is you got to keep them all aligned. Straight up in there. You can hear how hard it's having to work to get through that. Alright, we're not going to go much farther than that. We want it to be nice and flat so that it sits on the drill press. Alright. You can see how much work that is. Even getting this bolt is a lot of work. I'm literally just twisting it to get it back it off. I cannot pull it out. And we don't want to pull it out because it's going to hold and make sure this whole thing doesn't shift. Okay. So now that we have that done, now comes the fun. We're going to run it through the drill press again with our number 6. We're just going to go right through. We're going to do these 6 holes first. Then we'll put screws in those, then we'll do 7 and 8. And then once those are in position, we'll come back and redo this one, and we'll probably have to open this. I'll turn the camera back on once we get off the drill press so you can see this enlargement being done, just so you can see everything kind of go together. And that way, you know, I'm not cheating you of the experience. See you soon. Alright, we're back. The drill press did a wonderful job. So these are just on finger tight. As you can see, the whole plate is loose. So I wanted you to be able to see what we were able to do. So you remember we were using this little Black & Decker screwdriver trying to get all these in there nice and tight. Now, they're just all sliding in. These. Past that fastener. Okay, so all we're going to do is we're just going to go put these on finger tight. Swap out 2 of these for the flat nuts. Just so we're consistent. Sometimes your fingers just don't want to work. And Kevin was nice enough, he gave us 5 additional thread lockers, or lock screws, lock nuts, and 2 additional bolts. So if for some reason we need to use it, we have it. What we're going to do right now is we're going to just sit there. So it's on there, the switches are there. Alright, so we took the bolt, we ran it through. But unfortunately, if you can see that, it can't sit down inside the hole. So that is because the edge is rounded and we need to square out those 2 corners. So that's what we're going to do right now. We'll just knock that out real quick. There we go. I don't know if you heard it, it actually slid right in. Put our normal nut on. Tighten that down. The nice thing that does is that draws that nut into that hole, so even if it was loose, it's not going to be flat. Our spacer, our washer. I'm OCD about washers. There is a curved, smooth side, and then there is a flat side. I'm a firm believer that that flat side should be towards whatever friction surface it's going to be on. So right now I've got it sitting on the inside. Once we look at how the the pivot mechanism goes, we may flip that around, but that's just me. I always like the flat side going towards the largest flat surface and the curved side going out. Just aesthetic nuance that I like. I'm sure someone, mechanical engineer out there or something like that, will come back and tell us that there is a right way to do it and a wrong way, and you know what, I've probably been doing it wrong for years, but it works for me. All right, let's get this cleaned up real quick, get some aluminum out of here.